Yesterday we have seen solvable for P and solvable for X. If the differential equation of first order and any degree is given by y is equal to px plus f of p, this is known as Clairaut's form. Okay. Now, this is supposed to be very simple. So, suppose y is equal to px plus f of p is given to you. That means y is f of function of x and p, and especially there is a term px and all remaining terms are with respect to p. Then suppose we have y is equal to px plus f of p. If we differentiate this with respect to x, we get dy by dx, which is equal to p, which is equal to p into derivative of x, which is 1, plus x into dp by dx, plus f dash of p dp by dx. Whatever is the derivative of this required function, you will get it, and therefore what happens is you get this pp cancellation takes place there, and you can take out dp by dx, dp by dx common inside bracket x plus f dash of p is equal to 0, right? So dp by dx is equal to 0, or x plus f dash of p is equal to 0. So these are the two possible ways of looking at things, and if dp by dx is equal to 0, p is equal to constant. Okay, and therefore if p is equal to constant, that is what you end up getting. You replace p by c, replace p by c to get the solution. And maybe we will have to look at what this is going to imply. We will look at by taking examples. But essentially, Clairaut form can be solved by simply writing P instead of P, C. Differential equation is solved. Suppose problem number 1. Y is equal to Px plus P cube. Its solution is y is equal to Cx plus C cube. Okay. So there is no point in giving you many examples. We need to just look at what we can. Suppose another example is P is equal to tan Px minus y. Okay, you may solve this. Answer for this is y is equal to Cx minus tan inverse. So if you could identify that it is Clairaut's form, then replacing P by C is going to give you the answer, and it's very, very famous and favorite type of differential equation as far as students are concerned. Now let us look at what do we mean by x plus f dash of p is equal to 0. X plus f dash of p is equal to 0 implies x is equal to opposite of f dash of p. And if we substitute that value in the original equation, we get y is equal to p minus p f dash of p plus f of p. Okay. Now, depending upon what this f dash is, we will be able to actually see what this function is at the moment, because it is general. We cannot see, and therefore we can say that okay, this is how it is going to look like. But then this equation number 2 and the original equation number 1, right? They again form a family, parametric family of, so they together, 1 and 2 together is solution of D. The way we have done it yesterday for the last problem. It was not possible to express P explicitly and substitute back into the original equation. Similarly, if we are not able to express f of p and p explicitly because of this and put it back into the original equation, we might not be able to get the solution. Therefore, we will say that existence of those two equations simultaneously is the solution of differential equation in parametric form. Now, you will observe that 1 and 2, if they exist simultaneously, there is no constant, no c, no constant of integration is available. We will assume that these two functions simultaneously will give us the solution of differential equation, but there is no c, and because there is no constant of integration, it is not a general solution, or it is not a family of solutions. It is a one of a kind of solution that you have got. Because of this second factor that we got here, we have got one of a kind of solution, and it's called singular solution. And very soon we will see why these singular solutions exist and how do we get them without losing them, because typically in multiple choice correct questions, by procedure you will solve the differential equation, and by procedure, suppose there are 2 or 3 different functions by using which that differential equation is created, by procedure you will get those 2 and 3 by solving. However, unless and until you know the procedure to check whether there exists a singular solution or not and how to find it out, you may miss the third or fourth one which is there in the options. So we will learn at the moment. Let us go ahead and finish all the types of differential equations, and I will come back to you. So maybe you solve one more problem in this category. E3 is equal to x square minus 1 times p minus 2xy p plus y square minus 1 is equal to 0. Check, we can solve this. There is a correction. Instead of p, it is p square. X square p square minus 2xy p, so plus y square minus p square plus 1 is equal to 0. This makes it xp minus y bracket square is equal to p square plus 1. Therefore, xp plus minus y is equal to plus minus radical p square plus 1, which implies y is equal to xp minus or plus radical p square plus 1 Clairaut form. Therefore, solution y is equal to cx plus minus radical c square plus 1. This is going to be your solution in this form. Okay, so maybe here what is our f of p? Is it bad? F of p is plus minus radical p square plus 1. So f dash of p, if we find out, then it is going to be difficult to substitute it back. Just can we check whether we can find out singular? I am not aware. Can we check for singular solution of this? X is equal to opposite of f dash of p. If I want to, let us say first say plus. Suppose we take plus, then derivative of radical p square plus 1 is half into p square plus 1 raised to minus half into 2 is equal to opposite of x. So if you substitute this back, it is difficult because it is radical, etc., and you will not be able to get value of p, which you can go back and put it in this. It is little difficult, and therefore you don't get the singular solution. Maybe you can try, and if you are getting plenty, then we will observe what kind of singular solution it is and what is its geometric sense. Can we do it for earlier examples? Suppose this was p cube. So let us say this is p cube. F of p is equal to p cube. Therefore, f dash of p is equal to 3p square. Therefore, x is equal to minus 3p square. Therefore, solution of this differential equation is x upon minus 3 is equal to p square. For p is equal to radical x upon minus 3. So y is equal to radical x upon minus 3 times x plus radical x upon minus 3 times raised to 3. This is going to be the solution of the first differential equation, but it is little difficult to imagine what this kind of solution mean to us. For this will make sense if for the values of x less than 0, but otherwise this won't make any sense. But this is a singular solution. If you follow the procedure, this you will get a singular solution, and it is that. Okay. Eventually we will find out what these singular solutions are. Okay. So our Clairaut form is done because there is no point in doing more than these many examples. Just replace C by P or P by C is the only thing that you are required to do. Okay, so now let us look at higher order differential equations. Alice? नाही तेवढंच आहे. हो सोडलं तर वरती आहे, नाही तर मी येतो खाली. Higher order differential equations. They are going to look like this. F of x, it can be function of x, it can be function of y, it can be function of first derivative, it can be function of second derivative. Wait, sorry, not p, let us put it y dash. First derivative, second derivative is equal to 0. So how do we tackle them? It's something which we need to learn. Type 1. If we have a differential equation of this kind, essentially we are looking at second order. Higher is for your engineering study. Presently in IIT, maximum second order. Therefore, I have stopped at y double dash. So if it is independent, if it is dependent, if the dependent type 1 dependent variable is missing. Okay, depending on what you have. Suppose dependent variable is missing, that means y is missing, and you end up getting differential equation of this kind is equal to 0. Then how are we going to deal with it? Maybe before telling you trick, let me give you one problem. You try to develop your own trick. Problem number 1, example 1, x y double dash minus y dash is equal to 3x square. X minus x into y double dash minus y dash is equal to 3x square. Try to solve this. This is of the kind where y is missing. Okay, if y, which is dependent variable, is missing, then it is equivalent to say f of x comma p dash is equal to 0, and it looks like x comma y dash is equal to 0. So the method for x comma y dash will work for this, except that what we will get eventually is p, and therefore we need to deal with that p again. So substituting y dash is equal to p, and therefore we get y double dash is equal to dp by dx. We get x dp by dx minus p is equal to 3x square. Is this FOID? Yes. Hence you can solve it very quickly by finding out integrating factor, etc. You can deal with it, and the answer will be, solution of this will be p is equal to 3x square plus c1x. Now this is the first constant of integration that we have introduced, because we have really integrated it for the first time. Now if this p is dy by dx, which is equal to 3x square plus c1x, we can take integral of both sides, and we will end up getting y is equal to x cube plus c1x square by 2 plus c2. Now this c1 and this c2 are different because it was order 2 differential equation, and hence it is in line with what we were looking for, and hence this is the solution of given differential equation in which dependent variable was missing. Example 2. Y double dash is equal to 1 upon a radical 1 minus y dash square. Solve. Okay, if you use the same method, I think the integration is very simple. Therefore, you end up getting answer y is equal to minus a cos x by a plus c1 plus c2. Okay, one more of this type. T3 xy double dash minus y dash cube minus y dash is equal to 0. Solve. Okay, so let us write the complete solution of this. First thing is x dp by dx minus p cube minus p is equal to 0, and I think this is good. Dx upon x is equal to dp upon p into p square plus 1, which is equal to partial fractions, and therefore it is equal to 1 upon p minus p upon p square plus 1 times dp. After you integrate it once, this is ln or log x is equal to log p minus half log p square plus 1 plus log c. If you simplify this, we get x is equal to pc 1 upon p square plus 1 raised to half. Which is equal to, okay, if you have any trouble in understanding any of the steps, you should ask me. This is p square 1, I take it to the other side, and is equal to pc1 upon x bracket square, which is dy by dx bracket square plus 1 is equal to dy by dx bracket square into c1 square upon x square. If you cross multiply or simplify it, you get dy by dx bracket square is equal to, I don't think I am wrong, x square upon c1 square minus x square, and hence you should be able to solve it, because take root of this and then solve. Is equal to dy by dx is equal to plus minus radical, sorry, plus minus x upon radical c1 minus x square, and cross multiply and then integrate. You will end up getting one more integration constant, and therefore you get y is equal to minus 1 upon c1 radical 1 minus c1 square x square plus c2. This is your answer, where c1 and c2 are two constants of integration. Now if you take this c1 square out common, you get cancelled with c1, and what happened? This is 1 upon c1 square is left inside, which you can call as new c1, and therefore your answer looks little better. See, 3 square. That's it. Okay? Any doubt, difficulty before we shift on to the new? Independent variable is missing. So it's a function of g of y, y dash, y double dash is equal to 0. And you figure out how to deal with it. Even y double dash plus k square y is equal to 0. X is missing. Similar technique. Now, if we look at this, that independent variable is missing, so x is missing. So we can write this as g of y dash is our p, and if y double dash we can write in terms of p and y. If we can express y double dash in terms of p and y, then it is same as earlier. Okay, so y double dash is d2y by dx square. Is that correct? So it is dp by dx, p is dy by dx, and then differentiated again to become d2y by dx square, correct? And we don't want x, therefore dp by dy I will make, and I will make it as dy by dx, which is p times dp by dy. So with this arrangement, I am making this function g of y comma p comma p dp by dy. And therefore, I am treating this higher order differential equation by doing some trick or the other, converting them into first order differential equation, and therefore solving once and then solving it for p, we get two constants. I mean, we are supposed to solve it two times because it is second order differential equation. But then the trick is just manage to lower the order of the differential equation. So as far as this is concerned, our y double dash is p dp by dy plus ky square y, k square y is equal to 0. That makes it p dp plus ky square y dy is equal to 0, and hence p dp integrating you will get e square plus k square y square is equal to what? K square a square. I don't know why it is like that, but then it should make some sense, and therefore p square is equal to k square a square minus k square y square. So dy by dx is equal to plus or minus k times radical a square minus y square, and therefore variable separable, dy upon radical a square minus y square is equal to plus minus k times dx, integrating you get sine inverse y by a is equal to plus minus kx plus b, right? And therefore y is equal to a sine plus minus kx plus b. Okay, that is what it is. So you can write it as y is equal to a sine kx plus b. K is part of our equation, so it is not constant. So a and b are constants. Now I am not writing plus minus here because this a will take care of that plus and minus. Okay, so minus 1 will come out. Something like this is going to be the solution. Now see, what we are trying to do is, if y is missing, yes, we are able to solve. If x is missing, yes, we are able to solve. Now what we are going to do third is, if y dash is missing, yes, we are going to solve. Out of f of x comma y dash comma y double dash, if any one of these three is missing, then we are successful in solving it. Last part is done, we will do it, but otherwise we are successful in solving it. But if the given differential equation is of order 2 and it has got everybody, it has got x, it has got y, it has got y dash, it has got y double dash, then actually it is beyond your scope of supply right now, because that is what you are supposed to do in engineering, not before engineering. So higher order, only if one of the three guys are missing, then we can deal with it. The last one, independent, I mean, okay, I think we have to take one more problem in this. Second problem of this kind which you yourself should be able to solve, E2 y double dash is equal to y dash square. Solve this. Answer for this is some constant times e raised to c1x, or you may write it like e1 e raised to c1x plus c2, or maybe you can report it as log 3. This is equal to what? Y. Log of y is equal to c1x plus c2. Any one of the expression is correct. Okay. Again, only y dash is missing is not in our scope. Now the last type that we have is both x and y are missing. Type 3. Both so the equation essentially will look like both x and y are missing. Y double dash is equal to f of y, and does it mean x and y both are missing? I mean explicitly, x and y explicitly missing. Okay. So if the equation is of the kind y double dash is equal to f of y, what are we supposed to do? Okay, the trick is multiply both sides by 2 dy by dx into y double dash is equal to 2 dy by dx into f of y. Okay, what does this mean? This means 2 y double dash is equal to 2 y dash f of y. So it is d dx of dy by dx bracket square. So if I differentiate dy by dx bracket square, I will get 2 dy by dx and then second derivative of dy by dx. That is what this LHS is, which is equal to the same thing, 2 y dash f of y. Now you can integrate it once and you will get the dy by dx bracket square is equal to integral y dash f of y dx which is, if I replace this y dash by dy by dx, I get this dx cancelled and you end up getting 2 integral f of y dy, that is the simplest part means plus c1. Okay, and then after performing this integral, you can integrate it once again. So that has been the procedure. Therefore, now we are supposed to solve at least one problem on this, which I think you will be good in solving because it has something to do with physics. Have you understood what we have done here? Easy. So the problem, example. A particle of mass m moves along x-axis. Under action of force, f of x, that depends on position of the particle. It is given that motion starts at t is equal to 0 at the position x is equal to x naught with velocity v0. Form differential equation and solve. I will wait, then we will do it together. Okay, I think the starting point is force with so f of x is given to us, some force mass is given into t2y into x by dt square. This is the equation that we have. Now multiplying both sides by 2 dx by dt. RHS you will have m into dx ddx of dx by dt square, which is equal to 2 f of x dx by dt. Correct? That is what we have done. And if we integrate, then we will have 2 integral f of x dx by dt is equal to m. I think t should be here. M into dx by dt bracket square plus c1, or here plus c1. Now this is to be evaluated from x naught to x Okay, so I'm little bit messing it up. It is ddt of this, and similarly I can write it 2f of x ddt of dx. So this dt is not going to be there because this dt from both sides when we are taking integral will get cancelled, and it is 2 times integral x naught to x f of x dx into m, and this is to be evaluated from time 0 to t. Correct? Okay, so if this is the case, then what we are getting is half m dx by dt square minus half mv naught square is equal to integral x naught to x f of x dx. This is your energy equation. This is the constant part in it. One is potential energy, another is kinetic energy. अरे बरोबर आहे का, मी फार पूर्वी शिकलो, तुम्ही लेटेस्ट शिकत असणार. This is your kinetic energy, this is your potential energy.
So no, RHS is the work done by the force. RHS is the work done by the force.
This one?
Yes, sir. F of x dx integral.
Yes. But then if you take it to LHS, then kinetic plus potential is equal to constant, because this is fixed. This everything here is given to you, right?
This is actually the law of conservation of mechanical energy.
That is what it is. That is what I am trying to say.
Because f of x can also be written as minus du by dx, and if we write it like that, then we get potential energy.
Yes. So my involvement is up to this part. To which part? This part. Up to this part. This is mathematics. And then interpretation of this physics. But it is one and the same. Falls in place. Just write it down. Okay, so having learned different techniques of solving differential equation, now it is time to figure out whether we can solve some word problems. That means some description is given, you fabricate your differential equation and then solve it, and after getting the solution, cross check whether it makes sense or not. Okay, so the first word problems are always difficult. I mean, when you were young, you were kid, then also it is a problem related to ages of two sons or son and father. It is always difficult. Now we are going to have a word problem on differential equation. Write down. A rabbit starts at origin. And runs up the y-axis with speed a. At the same time, fox running with speed b starts at point c comma 0 and pursues the rabbit. What is the path of fox? Okay, now it is simple. Let me just explain it to you before I leave it to you. This diagram is like this. Rabbit has seen fox at c comma 0 when time is t is equal to 0, and this rabbit has got, say, rabbit hole somewhere on this y-axis. So it starts running in this direction at speed a, and cases speed of fox is small b, speed of rabbit is small a. We will take cases if a is less than b, b is less than a is equal to b later on. But then the idea is fox is going to catch rabbit. ते काय एकत्र खेळायला जाणार नाही आहेत दोघं जण. फॉक्सचा आयडिया, फॉक्सला भूक लागलेली आहे, ही गोइंग टू इट रॅबिट द मोमेंट ही कॅचेस. बरोबर आहे ना? आता काय म्हणजे फिरतायत, गोल गोल फिरतायत आणि डिफरन्शियल इक्वेशन आपलं बोंबलला असं नाही. Our differential equation has got story that fox is running to catch rabbit. So fox is running. So starting point of fox is here. Starting point of rabbit is here. And rabbit is moving in this direction. So what is the path of fox? So something like this. That path of will be there. But then you are supposed to find out equation of this. So that is the job given to you. I will wait for 10-15 minutes at least because it is going to be involved job. Now we know that curve is going to look like this. Okay, so at any point P x comma y, the fox will be looking at a rabbit, and therefore this is tangent at P. Okay, and this is the position of rabbit, which is 0 comma a times t. Whatever after time t, fox has reached this point and rabbit has reached this point. Okay, so if this is x comma y and this is 0 comma a t, then we can write down dy by dx at point P is going to be y minus at upon x. Is that correct? That gives us our differential equation xy dash minus y is equal to minus 8. Okay, that is the first thing that we get. And this is after time t, and therefore we wish to eliminate t, and hence we differentiate it one more time. So xy double dash plus y dash minus y dash is equal to minus a is constant times dt by dx. That is where we get xy double dash is equal to minus a dt by dx. Right? And now you need to do something for this. That is where dt by dx is equal to ds by dt by ds into ds by dx. Okay. Now ds by dt is the velocity, the speed of fox, and ds, distance traveled, ds upon dx is going to be, we need to find out. Suppose this is delta x and this is corresponding delta y, right? Then change in the, this is going to be delta s. Okay, so delta s is equal to radical delta x square plus delta y square. If we take out delta x common, so delta s upon delta x is equal to radical 1 dy by dx bracket square. That is what we will get. And limiting case, we will call this as ds by dx. That is available with us, which is supposed to be replaced here. And ds by dt is your small d. And you need to consider give one minus sign from your pocket, because as time, as delta s increases, delta x decreases. Okay, so doing all this, now we have got this differential equation which we can write as minus a dt by ds into ds by dx, which is equal to dt by ds is minus a by b, and ds by dx is radical 1 minus 1 plus dy by dx bracket square. And if you give that minus sign one more time, then I think is this minus sign correct here? X y dash minus y is this. So we get plus. So we have a final differential equation to be solved is x y double dash is equal to a upon b radical 1 plus y dash square. 1 minus sign for increasing delta s per decrease in delta x. Okay, so if you have any doubt up to this point, you can ask. Otherwise, this a upon b is constant, so you can deal with this differential equation, solve it, and it is order 2 differential equation. Therefore, you will end up having 2 constants. So I wait at this point. Okay, so basically x y double dash is equal to a upon b radical. So what is our idea of dealing with this kind of expression? Put y dash is equal to p. So we get p by dx is equal to k times radical 1 plus k square p square. And this is variable separable. Therefore, dp upon radical 1 plus p square is equal to k times dx upon x. After integrating, we get, what is the integral of this? Log p plus radical 1 plus p square is equal to, now k is already there, log df, this is log x, maybe c, so you can say that this is x by c, log x by c raised to k. This is after taking the first integral, and where the constant, this is c, let us call this as c is a constant of integration.
Excuse me, sir.
Yes,
Sir, in the last step, we have written minus a by b root of 1 plus dy by dx whole square, and then we have written a by b.
yes, it is because delta s increases, delta x decreases. So we are going to take a negative sign for this quantity. That negative sign will make it positive. That is what is the idea in the physical sense.
Sir, but in the first step, when we took y minus 80, haven't we already considered that?
In the first step, when we considered
dy by dx is y
slope,
minus 80.
this is just the slope of that line. This is just the slope of that line. And see, when we are writing it dt by dx or dx by dt, if it is upside down, dx by dt, then dx is reducing continuously. As time increases, dx decreases. Velocity is positive. Therefore, this term is going to have a negative sign in it. That is the consideration. I mean, see, finally we are supposed to check this with respect to physical things which are happening. Maybe you can carry that minus sign later on, and then we will realize that something different is happening. Maybe we can try that later. Presently, it is because of this correction, this minus has become plus here, but we can carry that minus sign later on and figure out what changes it really makes. Okay, so this is the integration of LHS. RHS is K log X K times log X plus log C1. Suppose I make, then at this stage, can I evaluate this C1? When t is equal to 0, the slope P is equal to 0. P is equal to 0 when x is equal to c. This is the initial condition that we have, and therefore we get log 0 plus radical 1, that is log 1, is equal to k times log c plus log c1. Is that right? Whatever I am doing. So log of 1 is 0. Log of 1 is 0. Therefore, log c1 is equal to k log c minus. So log c1 is equal to minus k log c makes it c1 is equal to 1 of k log c1. Okay, so if I put this k log c over here, I get this equation. So if I put log c is equal to minus k log c, I get RHS as k times, I had already written that, x by c fused. Let me write down RHS after evaluating the integral is equal to log x by c bracket raised to k. C1 is now substituted. Therefore, this is your first order differential equation. That is what you have got. And if you get rid of log from both sides, solving it for p, we get this is where we are going to stop right now because it is already 12:27. Now this is the first level of solution of differential equation because it was of order 2. We have reached this stage, and after this we are going to do it one more time where we will get the value of y eventually. Okay.